Hello, everybody. We're going to take you through the first part of regression theory. That is scatter plot and the residual analysis. In part two of the video, we'll answer some typical questions you'll see in regression analysis. All right, let's get started. First, whenever I have a data set, I like to make sure I know what I'm dealing with. And so what we're dealing with, especially in my case, I like to know what my X and Y are. We have two other pieces we won't be using for this video. We'll use them for future videos on multiple regression. So right now, what we have is X, cubic feet moved. So X will be cubic feet. And what this is we are a moving company. And this is cubic feet of product we are moving and how long it takes. So Y is the dependent variable. And that's very important to me. I need to know what is my X and what is my Y. This will be very important when I plug these into the equation. Now, there are certain size boxes that we are moving. That's what this is. Some are extremely large, and we classified them as large when they were. Again, we're a moving company. And whether or not the place we are moving the boxes out of had an elevator, yes or no. Again, these variables are extra variables for multiple regression. We will not deal with them today. So again, we're a moving company, hence that's why the file says moving. And we're moving cubic feet and how many hours it takes. So, first thing I notice, my Y is before my X. One of my biggest vain issues is that Excel, and if you're watching me, you'll see I'm highlighting, copying, and pasting because Excel needs my data in order, X, Y, or else I will not get a clean plot. And now that I got my data in order, X, Y, alphabetical order, I can highlight the data as such. And really, I want a quick graph. Before I do anything deep in the analysis, I want a quick graph of the data. That's where we go to insert. And I should have said right in the very beginning, we're using Excel 365, okay? If you have a different version, you'll have to look up on what to do in that different version, all right? Sorry about that. We are using Excel in this video, as it should be clear. So we go to insert, we go to recommended charts. Typically, it does pretty good. It gets the right one. If not, there are other options as you see. If you don't see the one you want, there is all charts, and you can go through all of these, like the scatter, and find the one you're looking for. They did get it right off the bat, so I'm going to click OK. And there is my pretty picture. So obviously you want to make this pretty for PowerPoint if you're going to give a presentation on this. Go to your, when you're not on the symbol, you don't have the design. When you're on the chart, you get the design button, plus axes titles. I always like to have my axes titles so when I know what I'm talking about later down the road. So this would be cubic feet, and that's cubic feet moved, obviously, and this would be hours on the job. So we have cubic feet against hours, and we probably need a nice chart title, not worrying about that for this video. All right, so here's my plot. The first things first. Does it look like a line could fit through there nicely? Is there not that much of a bend? And really, I don't see much of a bend. I am a little worried about these two dots here. I am worried about outliers. And so somebody could do an outlier check. And we leave this for advanced statistics, but you can do an outlier check to see if these are officially outliers or not. You can look into what is known as Cook's distance if you're worried about outliers. Let me put that in there. If you're worried about outliers, I'd look up information on Cook's distance. Great little tool in RStudio. You can also see my video on RStudio with the same file and see that I do it there. So if you're worried about outliers, you could do the Cook's distance and see if there truly are outliers. That's a little beyond our video right now. So where are we at? Well, I would love to have a prediction equation. I'd love to have a line through the data to see what it looks like. So on the plus, on the chart elements, trend line, go across to the arrow, you'll see you have more options. When you go to more options, this is what I like to see. All the options, if you think there's an exponential bend, a log bend, a polynomial, you want a square, a cube, you'd pick all these options. I'm going to keep it linear because that's what we're doing here today. It's linear regression. I'm going to click on both of these to display the equation and the R squared value on the chart. If you notice, they just popped up. That's awesome. Close this down now. I'm going to drag this up, and I see my equation right there, my prediction equation and my R squared. In part 2 of this video, I want to talk about each one of these numbers and what they mean to me. That's not this video. This video is to make sure, A, you can get a plot, which we've now got a nice plot, as you see here, a nice scatter plot. And so part A, go to scatter plot. Did it. Got myself a scatter plot, and it's labeled nicely. Typically in part B, before you do anything else, you should do a residual analysis. So a residual analysis comes in 4 words, L-I-N-E. That is, I got to check linear, I got to check independence, I got to check normal, and I got to check equal variance. You notice each one of these words, L-I-N-E, and that's my little acronym line. So we're going to check each one of these. To check them, you need to build a residual plot. So how does one build a residual plot? Well, thankfully, Excel does it for you, so we don't have to do it. To build a residual plot, you click on Data, make sure Data Analysis is up. If Data Analysis is not showing, you have to go through and examine how to get that added onto your program. It's a few steps. I'd Google how to get the Data Analysis icon in Excel, your version. Once you have it, we click on it, and there's a bunch of options. ANOVAs, data, where's my thing I really want to show you there? It's not there. It's descriptive statistics, really valuable too. Today, we're going to talk about regression. I want to keep it on point. Regression, so we click OK. So, in my prompt screen, it wants to input the Y. Good thing I have my Y. And yes, I am adding the title. Now I'm going to the X. And yes, I am adding the label. I check, confirm, make sure I got the right columns. Labels. Only click this if you highlighted the labels. You don't have to highlight the labels. If I have labels, I like to highlight them. If for some reason down the road you have to build a confidence interval for slope, you can adjust in here what type of confidence interval you need to build. If you want a 91, you'd highlight this, change that to 90. If you want 95, leave it as default. All right, down in this section, I always do new worksheet. And then it just makes it easier for me to see the residuals on a new worksheet. The information I want printed or plotted are the residuals, the plots, the residual plots, and the normal plots. These are the 3 things I look at when I do my residual analysis. Now that I got everything I want, I wait a few seconds, and I will title this Residuals. And I have my 2 plots. They're usually stacked on top of each other, so you have to move them around to see them. And they're probably pretty small, so if you elongate them, that'll be good. Now, a couple things to note. The reason why over here I did this piece, the prediction line, I like to make sure I get the same numbers, the 0.05, 2.3, right there. I like to make sure I do get the same, so I'm highlighting that, highlighting them in yellow to show you I got the exact same numbers. Oh, and by the way, I got the same R squared value sitting up there. So I know I've inputted the data correctly because my picture and my residuals are lining up nicely. Okay, so what do we have? Well, down here, we have the residuals. We haven't talked about those yet. What are residuals? Well, residuals are the errors, all right? These are the errors in your plot. See, what happens is you have the actual data, the actual Y values, and you have the predicted Y values. How does one get the predicted Y values? Well, you could do what I did, which is right here, build this chart, or you could plug each X into the equation, and that'll predict Y. So if you plugged in 545 into this equation, your predicted value when you plug in 545 for cubic feet will be 24.92 hours. If you notice that residual, my error is negative 0.9. Why? Well, let's look at what we actually had. We actually had 24 hours. Our prediction was 24.9. So we are over predicting by 0.92, and that's what the negative represents. We are over predicting by 0.92. What I want to do is take a look at these residuals and make sure there's no pattern in them. How do I do that? That's what this is, the residual plot. We have the feet, so you have your X plot and your error plot. And I got to be careful. All right, so what is the residual equation? The residual equation is y minus y hat. I want to make that very clear, something you should memorize. What is the residual equation? Well, it is y minus y hat. And so 24 minus 2492 is that. And what we're doing is we're looking at the residuals, the errors. And when we do this error check, linearity, independence, normal, equivariance, we're really zooming in on the residuals. So linearity, what I'm hoping for is if I drew a line straight across, two horizontal lines straight across, you wouldn't see much of a pattern, just really scatter along the way. I am worried, though, same issue with the outlier worry, I am worried about these two dots because they don't seem to play nicely. Everything else here seems scattered. I like scattered. So honestly, in the linearity, the scatter is good. And so I'm going to put an XXX. I like it. I like this check. Independence. You really should run a Durbin-Watson, but that is an advanced test. So what we do here is we think about the data. Independence is all about worrying about one value collected right after another value. Was time a component? That is, when this was collected, did it affect this value? Or did this value affect this value and how you collect it? Like gas prices, if you collect them per hour, gas price in the last hour has an effect on what the gas price is this hour. In this case, I don't see any issue with how this data was collected. It was not collected daily, quarterly, weekly, any of that type of scenarios. Independence would be violated. And if you violate this section, welcome to time series analysis. When you violate this, or there's other things, but time series analysis is usually the way to go. All right, equal variance. I'm going to join there. I'm looking for growth / decay in the residual plot. So let me go to that residual plot. Do I see, as I look left to right, any growth or decay? I don't want to see growth. I don't want to see decay. I want to see them pretty much scattered and stay the same amount of scatter left to right. Once again, I am thinking really hard about chopping at 1,000 and doing my investigation prior to 1,000 and my investigation after 1,000. When you get used to doing residuals and regression, you kind of get used to sometimes cutting your project into pieces. And because right now this little growth kind of bothers me, but overall I'm going to say we're good because the growth isn't that bad. Normal, well, that's where I have an issue. The normal, by the way, is done with the normal probability plot. What it does is it takes your y value, the hours, and plays them against where they should be in a normal distribution. It kind of lines up the hours and places them. If you notice, overall, the data is very normally distributed, except for at this end. This bend here, this bend is not good. This bend means either we picked the wrong model or once again, you got some outliers. Again, I'm really believing if we make a cut, we would deal with it. But without me actually doing it, I'm just hypothesizing. But this bend at the end, this visual bend has me worried. So I'm worried, so I would do the NBP plot. I would look at it, and I am worried here. And that's my residual analysis. I look at linearity, independence, normality, and equal variance. I am worried about normal, and a way for me to get around the issue would probably right now state I'm going to investigate 1,000 feet and under and 1,000 feet and over. There seems to be such a discrepancy, I would do that. But that is up to the professor to decide what they're doing. Thank you for watching my video. I hope you stay tuned for part 2.